Hello guys, let's continue our lecture, Process Control 1. I think last time we reached this slide, 22 I think. We were discussing, and we're still discussing, the quality and quantity, or the importance of control system. We discussed the safety. Now we will discuss number 2, production specification, which means quality and quantity. Let's see this red line. What the red line connected? It connects the flow of the inlet into the control valve, which means the quantity or the flow rate. The flow rate should be constant, should be smooth. I mean, we always try to keep the production rate smooth by the control system. Why is that? Because if we not, there will be a disturbance in separation. There will be the product will not be, in good quality enough. Also, the process of heating. If we increase the process of heat, we may disturb the concentration of one product B or product A. This is the role of control system, to control the flow and control the heat delivered to the flow. This way we can control the quality of the product. Next slide. To see, desired concentration of B can be achieved by adjusting the amount of heat. The amount of heat can be adjusted to reach the desirable concentration of product. Here he mentioned product B, but whether E or A. Environment regulation. Environment laws. What they mean by this? They mean we should not release any substance harmful to environment. This is also the control device play important role in this. That means it's banned any substance to be released into the atmosphere. And finally 5, economics. See the red line here? Economics, which means how much heat we are delivering. The steam, of course, it costs money. The steam comes from boilers, and in the boilers we use, for example, natural gas or LPG or whatever, or coal or anything to heat the water and convert it to steam, which means when the quantity of steam increased, we lose a lot of money. If this goes, without any benefit. How we control this? By this analyzer. If this analyzer detects that the concentration of this product is okay, so it will stop, or it will control the quantity of the steam delivered, or the quantity of process flow in this control valve. In this way we can control the economics, or the lost money in the boilers. Now we will move to fundamental and concept of process control system. The fundamentals of process system. We will start with the old times, how they start controlling. We will classify the control system and see how it works. Just a second. There are 3 stages of control system. Manual control system. Manual, that means it's controlled by manual. It's human responsibilities. And there is automatic control system. I remember in the class I give you an example of the water tank. When we put a float to stop the flowing when the level goes to maximum. This is mechanical, but manual control system is like this one. Just there is an example coming. And the automatic control system could be mechanical and could be like the example I give you, and could be electronics, by software and electronic devices. The mechanical control system could be hydraulic or pneumatic. I assume you know what hydraulic is. The hydraulic, that means the power drive is hydraulic, is liquid, and the pneumatic is the power drive is air. Human control system, that means manual control system, is like what? Like the picture you see now. You see what's going on. There is a tank, and there is fluid coming from the top, and this is the inlet, and there is the outlet. When this worker stands on, and he holds the manual valve, he sees from the side glass the level of the tank. He was instructed when the level reached certain point to close or to open. That means he is now controlling the level. Suppose 50%. When the level goes high, he increase the opening position of the control valve in order to maintain the level on 50. And contrawise, if the level goes down, he closes the valve, this manual valve. This is human control. What about the other? There is another example. For example, this heater. This is process heating. You see the temperature gauge. Just a second. As you see in this example, this is also manual control. This is a worker or operator who controls the quantity of the fuel gas coming to the heater. This fuel gas heating this whatever inside this tubing. How he controls this? He sees the temperature. When the temperature reaches certain point, for example, the set point is 100 degrees centigrade. When he keep opening the fuel gas until it reach 100. If it goes above 100, he will close the valve. And the contrawise, if the temperature goes down, when the temperature goes down, if the quantity of the material inside the tubing increases with the steady rate of the fuel gas, the temperature may go down. It may go down, and in this case, he will open more the hand valve to allow the more gas to flow. أظن مفهوم صح. كله manual control. يشوف التمبريتشر، يفتح الغاز أو يقفله على حسب تكون الحرارة في نقطة معينة اللي هي مضبطة. أما about the mechanical control, this is exactly the example I give you. Floater, flow tank. This is a storage tank, water or whatever. When the level goes up, the floater will go up also with the fluid and closes the inlet. Closes the inlet, and the water will stop flowing. This is mechanical. Same example here. If you notice that there is a steady flow here, and there is a gate valve here, and whatever, if the outlet is open or closed, no problem. The control is with this floater to control the inlet flow with certain level. When the level will almost reach maximum, so the floater is in the above position. So this valve will, sling will allow the valve to go down. to go down and closes the inlet. أظن مفهوم. أما electronics, if you see, this is the same example in the manual control, but we install here a control valve which work pneumatically with electrically. This is how it works. This is a main important device in this process, which is the controller. If you remember, I told you there is three major elements of control system: the sensor, this one, the controller, and the actuator. The sensor senses the temperature here, transmit the signal to the controller. Here the green number is the set point, which means I set the controller to keep the temperature of the material inside the tubing on 85 degrees centigrade, for example. This is set point. And the red one is the actual temperature. When the temperature stays around the set point, the control valve keeps steady. The opening position keeps steady. If the temperature goes down, the signal coming to the controller, and the controller will process the data and give the signal to the actuator, this control valve, to open to allow more gas. And otherwise, if the temperature goes up, it will close this controller. I think it's clear. أكيد واضح صح. الكنترول سيستم يكون الحرارة لو ارتفعت، هذا بيعاير السيت بوينت مع الداتا اللي موجودة عنده، بعدين يعطي خبر للأكشويتر، يعطي سيجنال له إنه يفتح. هذا سيجنال كهربائي إنه يفتح أو يغلق. Okay guys, let's start now with the classification of control strategies. What is the strategies we have here? The control system, as a system, the control strategy can be classified into three sections or three types. The first one is open loop control system. The second is closed loop control system, and the third one is feed forward control. What are they? Let's have an example to define them. But from the word itself, loop control system, open loop, that means no feedback. The result is not important. There is no sensor to sense the results. But closed loop control, next slide. For example, for open loop control system, let's start with open loop control system. Like what? The open loop control system is also known as a control system without feedback. There is no feedback. The result is not important, but it is control system. In open loop system, the control action is independent of desired output. The manipulated variables, or the variable you control, is independent from the desired output. The desired output is not depends on the control actions. Like what? See this example, heat exchanger. I think most of you familiar with this drawing, with this device. This is called heat exchanger. When we want to exchange the heat between two matters, for example, process stream, that means the liquid, we want to change the temperature, for example, to increase, as long as there is steam, that means we need to increase the temperature of process steam. The process steam goes into the heat exchanger, into the inside the tubes. This is in the middle here, there is a tube, and the shell between the tubes, the steam supplied, and here is the outlet of the process stream, heated stream with temperature. We need to increase the temperature, for example. As you see, is there any control? Of course, this valve. I think it will open with a certain position, for example 20%, 30%, whatever, and the process steam temperature will keep raising until I don't know, it's open loop. It is open loop. That means this temperature is not depends, it's not related or is not connected to the quantity of stream. If we connect the temperature here to the controller and from the controller to this control, that means this is closed loop. We close the loop, which we are supplying the steam according to the desired temperature. But here it's still open loop. Let's see another example. Automatic washing machine. You just put the soap, put the water, start it. It will run for some time. It will run for some time and give you the result. But you don't know whether the clothes are cleaned enough or not. In the machine, the operating time is set manually. You set the time, 5 minutes, 3 minutes, or whatever. But after this time is over, the machine will stop. But do you know when you open and remove the clothes, are they clean enough? The result is not depending on the time. Next. Other example is automatic control traffic. The automatic control traffic, which has 3 lights. It's controlled the traffic by setting the time of each lamp. For example, the red lamp time set point is, for example, 30 seconds or 1 minute. When this time is over, it will change to yellow or to green. The result is not important here. Sometimes maybe there is a lot of cars still in the traffic, and the color becomes red again. In this example, it's open loop. which means النتيجة مش مهمة. ما فيش رابط ما بين النتيجة أو السيت بوينت أو الديزايربل ريسبونس زي ما احنا عرفنا الكنترول سيستم مع المانيبيوليتد فاريبلز، مع المكان اللي نشي نتحكم به. خلونا نتعرف على النوع الثاني advantages. لسه احنا لسه في الاوبن لوب سيستم advantages and disadvantages. What is the advantages؟ شوفوا بسيط simple. Open loop control system are simple, economical, less maintenance is required and not difficult. مش صعب، not difficult يعني وما فيش maintenance, doesn't require that much of maintenance. Very simple system. طيب وش disadvantages؟ Disadvantages is it is inaccurate. ما دام ما يعتمد شيء. As long as it is not depend on the result, it is not accurate. You don't know whether the result is satisfactory or not. Unreliable يعني مش reliable يعني مش موثوق فيه يعني. Slow and optimization is not possible. ما يمكن تعمل optimization. You cannot optimize it. You cannot increase or decrease the quality or the of the result. This is open loop system. Let's see the closed loop control system. Closed loop control system are also known as a feedback control system. In the closed loop control system, the control action depend on the desired output. في رابط ما بين desired output وما بين manipulated variable أو الكنترول أو المادة اللي نعمل لها control. In closed loop control system, the output is compared with the reference input. يعني أنت بتحط set point and set point وتعمل compare يعني تعمل مقارنة ما بين الاوتبوت المخرج أو الاوتبوت with this reference set point. And error signal is produced. بينتج error. As long as the difference between the set point and the actual value is big, the error is big. The error signal is fed to the controller. بعدين error signal هذا transmitted to the controller, and the controller try to reduce this error and desired output is obtained. When you reduce this error, the desired output is obtained. Let's see the same example of heat exchanger. What's the new here? We installed temperature transmitter here to sense the temperature, and this sensor connected to the controller, temperature controller, which is supplied with set point, and it is connected to the control valve of the steam. What's going on here? If the temperature goes high, for example, the controller will make sure to decrease the quantity of the steam in order to reach the desired set point. هذا بالنسبة للمثال هذا. In room we need to regulate the temperature of air conditioner. الاير كونديشنر مثلا لو معنا مكيف air conditioner في الغرفة, we need to control the temperature. There is a thermostat or sensor of the temperature. You set it on 20, then if this thermostat senses the temperature, if it reaches 20, it will shut down the compressor of the air conditioner. صح ولا أنا غلطان؟ Advantages: this system is more reliable, faster. A number of variables can be handled stimulantly, and optimization is possible. يعني ممكن تعمله optimization, ممكن تعمله تحكم, يعني ممكن تزيد تنقص. Disadvantages: شوية expensive, maintenance difficult. يعني معك انت أجهزة جديدة, معك sensor, معك يعني need maintenance, difficult to and sometimes complicated installation. طيب النوع الأخير اللي هو feed forward. The objective of feed forward control is to measure the disturbances. الآن معنا حاجة جديدة داخلة في الموضوع في الكنترول سيستم is the disturbances. هذه an external element that can affect the result. An external element in the area you control that can affect the result. such as ايش هتعرفوها بالأمثلة. And it's feed forward control system measures this disturbance and compensate from them before the control variable deviated from the set point. يعني قبل ما الكنترول variable تكون away أو تكون بعيدة من الset point, هو بيعمل كنترول بيقيس الديستربنس, وعلى أساسها بيقدر يعمل generate لنيو signals, generate suitable control system. When the feed forward control is applied correctly, deviation of the control variable is minimized. يعني عندما يكون فيه الفيد فورورد كنترول is applied correctly بالضبط, لما تربط أنت الحاجات بالضبط, الديفيشن أو البعد عن السيت بوينت يكون minimum. يعني لو تذكروا الرسمة اللي أنا رسمتها لكم, بيكون الجراف on the set point line بالضبط. Feed forward controller measure the disturbance variable and send this value to the controller. يعني بيقيس الdisturbance and let the controller to manage it and according to this value the controller will adjust the manipulated variable. For example, مثلا in the example of heat exchanger, the manipulated variable is the quantity of the steam. كمية الستيم اللي داخلها هي اللي تعمل لها انت تغيير, اللي الكنترولر بيتحكم بها. For example, same نفس الهيت اكسشينجر. هذا هو الفيد فورورد كنترول سيستم. في معك انت بروسيس ستريم داخل, في معك فلو. هنا الديستربنس مثلا الكوانتيتي الفلو حق الداخل. تخيلوا على المثال السابق لو ما فيش الفيد فورورد سيستم, الفلو when increase the flow it will affect the temperature. The temperature fast enough بحيث ان الستيم will not the response to the control valve of the steam will not be enough to reduce the actual value. يعني هذا يسمى الديستربنس في هذه الحالة هي الفلو الداخل. لذلك في الفيد فورورد كنترول سيستم هو بيتحكم, بياخذ الفلو وبياخذ التمبريتشر وبيعمل كومبنسيشن, وعنده السيت بوينت وعلى أساسها ممكن يتحكم بالفلو حق الستيم من شان يضمن ان هنا مرتبطة. هذا نوع. بس في النوع الثاني and the other type, this transmitter will be connected to the feed forward controller. هذا هو اللي هو perfect control, اللي هو when you measure the disturbance and everything around. Advantages: if all sources of the disturbance are known and this value can be measured correctly. هذا perfect control. يعني إيش؟ ما فيش disadvantages. perfect يعني. Disadvantages: no corrective actions for unmeasured disturbance. In industrial applications, feed-forward control should be used in combination with the feedback control. يعني الdisadvantages الوحيدة له إنه it cannot be correct the disturbance. يعني في المثال السابق الفلو ما ممكن يتحكم هو بالفلو، ما فيش فلو ميتر هناك ولا كنترول فالف في الفلو، بس هو لأن هذه disturbance يعني، بس هو بيتحكم إيش؟ بالحرارة. شوف هذا المثال الأخير the feed forward control system. هذا المثال هو اللي هو perfect control، يعني رابطين البروسيس ستيم داخل من هنا، في معه فلو كنترولر، في temperature controller inlet temperature، وفي outlet temperature، وكلهن إلى الفيد forward controller with set point and it control the steam quantity coming here. أظن enough for this video.